Problem 2 says a furlough is an antiquated unit with a length of 220 yards. Another antiquated unit is the fortnight, which is a time of 14 days. If an object has a speed of 1 furlough per fortnight, what is its speed in meters per second? To solve this, we need to convert from furlough per fortnight to meters per second. We're given 1 furlough per 1 fortnight and can first convert furloughs into meters by saying 1 furlough is equal to 220 yards, as stated in the problem. We can go from yards to meters because we are given the conversion in the problem statement. And then what's left is to convert fortnights into seconds. 1 fortnight is equal to 14 days. 1 day is equal to 24 hours. 1 hour is equal to 60 minutes. And 1 minute is equal to 60 seconds. We can see how all of the units, except for meters per second, cancel out. And if we were to multiply across all the numbers on top and divide by the product of all the numbers on the bottom, we would get 1.66 times 10 to the negative 4 meters per second, which is answer A. Problem 3 says that a ball is dropped from a height of 6 meters and asks how long does it take for the ball to strike the ground. If we were to draw a picture of this, we'd have the ground, the ball. Because it's dropped, we know that its initial velocity is going to be equal to 0. And this would be a height of 6 meters above the ground, which means that our starting height, we can say, is 6 meters, and our ending height is 0 meters. To solve this problem, we will need to use a kinematic equation. The equation y equals y naught plus v naught yt plus 1/2 ayt squared will get us to the correct answer. From our picture, we see that the final height is 0, the initial y velocity is 0, and because this object is going to be falling and is therefore in free fall, our acceleration in the y direction is going to be due to gravity. With these simplifications, our equation now has this form, which we can solve for t, as t equals the square root of 2y naught divided by g, and then plug in numbers. So y equals 6 meters for our initial height, and 9.81 meters per second squared for the acceleration due to gravity. Plugging those numbers into a calculator, we get 1.1 seconds, which is answer choice D. Problem 4 says what is the average acceleration between time 1 equals 2 seconds and time 2 equals 5 seconds of an object with a velocity as a function of time given by the equation shown. The equation for average acceleration is change in velocity per change in time. Given that they tell us time 1 and time 2, to figure out the change in velocity, we'll want to know what is the velocity for t equals 5 seconds, and subtract from that the initial velocity of this time frame, which occurs at t equals 2 seconds. For our time in the denominator, that would be 5 seconds minus 2 seconds. To calculate the values in the numerator, we can use the provided equation. To figure out the velocity at t equals 5 seconds, we plug in t equals 5 everywhere we see a t. So we'd have 15 meters per second plus 2 meters per second squared times 5 seconds minus 1 meter per second cubed times 5 seconds squared. Plugging this into a calculator, it actually equals 0 meters per second. Repeating this same process for t equals 2 gives the following: 15 meters per second, 2 meters per second squared times 2 seconds minus 1 meters per second cubed times 2 seconds squared, and this is equal to 15 meters per second. Taking these values and returning to our equation for average acceleration, we can substitute 0 meters per second for the velocity at t equals 5 and subtract from that 15 meters per second for the velocity at t equals 2 seconds. In the denominator, we have 5 minus 2 gives us 3 seconds, and we can divide 15 by 3 to give us a negative 5 meters per second squared for our average acceleration, which is answer choice B.